Hi everyone, welcome back to another video. In this video we will be discussing about normality test of variables. So normality test is a very important concept in data analytic part, because once we know the data follows normal or not, after that only we can take which test will be appropriate for our analysis. So as you can see in my screen, there are 5 variables. 2 are numerical and 3 are categorical. So I have already shown you in my previous part how to check the descriptive statistics of each variables. So in this video, just like how we found the descriptive statistics, we will also find whether these variables follows normal or not. Remember in mind that normality test can only be applied to a numerical data type. That means here we can only apply or check for the variables age and gestational age. For these two variables only we can check whether the data follows normal or not. Once we confirmed it is normal, we have parametric test. If it is non-normal, we have non-parametric test. So this will be discussed in the next part of this video. In this part we will only check whether these data follows normal or not, and I will give you a hint to find the outliers present in this data. If this data contains outliers, I will show you how to find the outliers and rectify it. So let's begin our journey. So at first, as I said, for scale variables we will check whether the data follows normal or not, that is age and gestational age. So I will go to analyze. On descriptive statistics there will be an option of explore. I will click on explore. A pop-up window of explore will be shown in our desktop. What you have to do? You have to select those to scale variable and add to dependent list. Once you selected it, there are some options. So we will be doing or checking some of the options that are necessary for our analysis. We will be excluding other options that are not required at the moment. So I will click on statistics. I have descriptives. I have shown you the descriptive statistics in the previous video. If you haven't watched it, you can go to the previous link. So you will have an option of outliers. It's a very important option because this will help us to identify whether there is an outlier or not. So I will click on continue. On the plots, I will click on histogram. I will click on normality plot with test. Default there will be stem and leaf. You can exclude it. There is no use of stem and leaf in finding the normality test. So you can click on histogram. It's a very important plot to check the normality test. Also the normality plot with test, it's also a very important plot. Under this comes the box plot. So you will click on continue and you click on both here displays. It should be statistics and plots, and click on OK. The output will be presented in the output screen of a SPSS. So at first we will have the number of samples summary. So summary of number of samples. We have 79 samples. If there are any missing values, it will be shown here. So if your data is an incomplete, you can identify it here. If it is unclean, you can identify it here, that if there are some missing values. So here I have no missing values, so my data is absolutely don't have any missing values, it's perfect. So now I comes to descriptive statistics. So these are my descriptive statistics. So here I am checking the normality. So this is not that much important, but the important variable or important concept in this descriptive statistics for normality is the minimum and maximum value. Why? Because we will find out later. I will come to those portions why minimum and maximum values are most important when checking the outliers, because outliers plays a role in normality. So extreme values, this we have clicked an option of outlier. So for that we have and plot data or summary of extreme values. That is for age, my highest value is 37, next highest is 36. It will come in and descending order. Lowest, my lowest value is 19 for age, then comes 20. So it goes in ascending order. For gestational age, likewise, 36.6 is the highest value. For lowest, it is 25.4. So this plays a very important role in finding the outliers. So how is it? We can come to that after checking the histogram. So we have provided an option of histogram. So histogram is here. From this, can you say this data follows the normal or not? Can you say it? We can't say it, right? We can't be 100% sure this data follows normal or not. But there are some options. We can see that there will be a lower and there is an higher end. So it's following approximately a normal distribution, but we have to confirm it, right? So if you want to see a curve, you can double click on the graph and there will be an option here, this option of giving a curve of normal. You can see a curve there. When you close it, it will be automatically applied to your output. So from this, you can't be sure. To make it sure, what you have to do, you have to test this table. You have to check this table. This is the most important table. Test of normality. So here they are given two tests, kolmogorov-smirnov test and shapiro-wilk test. So two tests are given. Always remember, whenever the p-value is less than 0.05, we will take that variable as non-normal. Which is the p-value here? Sig. The data given in the sig function act as the p-value for kolmogorov-smirnov and also for sig in shapiro-wilk. This values act as a p-values. So what you can see here? Here for my age it's 0.025, which is far less than 0.05. What does that mean? Age does not follow normality. And you can see from shapiro-wilk test it's giving the same result. Age does not follow normality. Even gestational age is far below from 0.05. It shows our gestational age does not follow normality. So from the histogram, you can't conclude whether this data follows normal or not. When we check on our shapiro-wilk test and kolmogorov-smirnov test, clearly indicating that our data does not follow normality. So how to confirm it once again? So the first test is kolmogorov-smirnov test, second test is shapiro-wilk test, third is histogram, fourth you can go for normal Q-Q plot. But as you can see, the normal Q-Q plot, the data is lying along the straight line, which means it follows normality. Now as you can see, our three options shown that it is non-normal, and here one option is showing that it is normal. Now what we have to do, we have to take a decision. You can go below to check another test of box plot. You can check on box plot. So how to check the box plot? You can check on the whiskers, that is the tails. If the tails are different in length, then it shows non-normal. If they are almost same, then it shows normal. What you can see here is both the tails are almost similar, so it shows this is a normal data. Now there is a contradiction. My three options are saying it is not normal. My two options are saying it is normal. Now coming back, so now these options are saying, three options are saying non-normal and two options are saying it is normal. What you have to do, you have to check for outliers. Maybe because of the outliers these tests are showing non-normal. So what you have to do, you have to go back to our extreme values. On extreme values you can see the highest value is 37. For my age, I have considered from age group from 15 to 40, and I got 37 as the highest value, which shows there is no outlier in my group, in my study. In the age group there is no outlier. Even when I check the lowest value, I got 19. My study consists of from 15 to 40. That means 19 is included, there is no outlier. I come back. Also you can check from minimum maximum value. I said it is important. Why? Because from here you can get an idea of the whether there is an outlier present or not. Same value will be shown in the extreme values also. So from here you can get an idea, and also you can get a more intensified idea from these extreme values. Next we check on normality. So now I have to manually take a decision whether this data follows normal or not. So what will I do? I have to take a decision. Now I have three options of non-normal and two options of normality. I go back to histogram. Histogram almost is like a normal. I have taken earlier this as non-normal, but I have a doubt again. I have to take a decision. So my kolmogorov-smirnov test, these are the tests. These are the statistical tests. It's showing that these follows no normal. But from my box plot it contradicts. So I have to make sure this follows normal or not. I comes to my histogram. When I plot my normal curve, it's almost like a normal. So here you can see that almost 0.005 difference was there to become normal. So So what I will choose in this case, my preference is that this data follows normality. This is my preference. So if you have another preference of going with non-normal, it's okay. Why? Because kolmogorov-smirnov test and shapiro-wilk test shown that it follows non-normality. But box plot and my Q-Q plot and my histogram almost shown that this follows normality. So I consider this test as normality. So now you have a doubt that why I have considered normality, why I can go for non-normality. So there is absolutely no mistake if go with non-normality, but whenever you think a data follows normality, it's better to take normality, because when we test a hypothesis or when we go for the inferential statistics, normality tests have an higher accuracy rate. So if we say there is a difference between two groups, and if you use the normality test, it has an higher accurate result than a non-normality test result. So that's why I took the age group as normal. Now coming back, I have one more gestational age. It's absolutely non-normal. It's giving kolmogorov-smirnov and shapiro-wilk test. I close my eyes and I will say this follows non-normal because it's like less than 0.001. The p-value is less than 0.001. To confirm, I will go again to histogram. You can see definitely this does not follow non-normal. It is a left skewed distribution. So how to say whether it is left skewed or right skewed? We will go with the tail. So its tail is going to the left, far left, so it's left skewed. If this tail goes to the far right, it is right skewed. From the histogram, I get that this data definitely don't follow normality. So when I go for the inferential statistics with this variable, I have to choose non-normality test. So there is no other options for me. If I choose normality, a test with normality, my result will be absolutely wrong. So coming back to make sure my Q-Q plot data is not lying along the line. Here it's going far away from the line. What does it indicate? Non-normal. So I have to make sure this data are not outliers. Maybe sometimes due to outliers our data can show non-normality. So I have to make sure this data does not follow outliers. So how to identify outliers? I have shown you can use minimum maximum method. That is one method. Second, you can use the extreme values method. Third is box plot. I will show you in the box plot. You can see in the box plot, whenever a data falls apart from these two lines, these are the end lines, upper limit and lower limit. This is the lower limit, this is the upper limit. When this data falls apart from this upper limit and lower limit, it's an outlier. So what does it mean? My data set of observation 63, it has a value of around 28 point something, so it's an outlier. It is far extreme from other data set. Also my observations of 42, the observation number is showing, it's not the value, it's the observation number. My SL number, my case number 42, it is below 28. Oh, it's around 27. It's an outlier. Also, my observation number 64, which is below 26, is an outlier. So this outlier is the cause, maybe can be the cause, this of non-normal. So these are pulling our data set to the left skewed. Even from my box plot, you can see the whisker. These differ much away. This is very short line. Here I have a very large line. Shows this data follows non-normality. So once you have an outlier, what you have to do, you have to go back. So now my gestational age does not follow normality. So I am coming back to my extreme values. Now I know my gestational age can lie between 20 and 40 in normal people. So I come back to check. The highest value is 36.6 and the lowest is 25.4. So it's lying in my range. So it's not an outlier, but the distribution of my data set is more like non-normal. It's more like left skewed. So whenever you find an outlier, you will go back to your data set and check whether that value is lying far away from your mean value or far away from rest of your values. For example, if here it was 136 due to typo error, it will be shown here it was the highest value. Then I can go back to my data set and I have to rectify it. So there are many ways of rectifying it. If it is a typo error, you can rectify it. If it is 136, I can put 36 unit. I know if I took the values, then I know how much value it can be. So maybe when typing or entering to my desktop, I committed an error, so I can rectify it. Other way, if you think no, this does not this is an original value 136, is a very rare case, what you can do? In that case, there are many options, but I would suggest that we have normality test, especially for whenever data does not follow non-normal. So instead of going, if it is a one value, one observations, yes, you can use your mean value or your median value and you can put there, but there are more than 5 values. What you have to do is you have to go for non-normality test. So non-normality test is especially built to sustain outliers. So there is no problem when you use those values. So here this follows non-normal and here this follows normal. So I can use 5 options to confirm it follows normal or non-normal. Kolmogorov-Smirnov is one test, shapiro-wilk is second test, histogram, Q-Q plot, and also my box plot. Now if you see a contradiction, you have to check again and you have to take a manual decision. If it is more like going for normality, then you have to go with normality. But in the second case, you can see that there is no form of normality. Then you have to go for non-parametric test. That's all for today, and we will be discussing a real case scenario in which we use the normality test and non-normality test on an explanatory variable in the later video. Thank you.